is equal to factors of 36 and Q is equal to factors of 54. I list the numbers in set P and Q. So in set P we have factors of 36. So set P is equal to factors of 36, which is 1, 2, 3, 4, 6, 9, 12, 18, and 36 itself. So when we talk about factors of a number, that means a number that has a multiple of that specific factor we are looking for. So if we multiply 1 by 36, we should be able to get 36. 2 by 18, we get 36. You multiply 3 by 12, you should be able to get 36. And multiply 3 by 9, you should be able to get 36. Multiply 4 by 6, you should be able to get the same number as well. And the factors of Q, so we have set Q, which is the factors of 54. So we have 1, 2, 3, 6, 9, 18, 27, and 54 itself. Okay, so 1 multiplied by 54, you should be able to get 54. 2 multiplied by the numbers here we can check or cross check by multiplying, and we should be able to get the numbers. Or if even there is no specific number multiplying another number in the set, there should be a number which multiplies itself to pass the same number. So in each of these cases, you can do to verify if you are on the right path. So we are done with I, and I says we should find P intersection Q. So when we talk about intersection, it means a member in a particular set found in the same in another particular set, which is the same number. Okay, so if we are looking for so this is I, right? So I, if we are looking for P intersection Q, we should go straight to set P and Q. Any number found there is an intersection, and we can see 1 is in both of the sets, and we can also find 2 over there. So 2 should be one of the sets, and we can find 3 is 1. There is 4 in set P, no 4 in set Q, so it's not that. We can find 6 in both sets, so 6 is an intersection. We can find 9 in both sets, 9 is an intersection. 12 is in set P, not in set Q, so it's not an intersection. 27 is in set Q, not in set P. We cannot have it as an intersection. We have 18 in both sets, so 18 should be part of intersection. 54 is in set Q, it's not in set P, so it's not an intersection. So our intersection should end on 18. So P intersection Q is 1, 2, 3, 6, 9, and 18. Okay, and question I states that's question I alpha. So that's question I alpha. So we are going to solve the question I beta. So the question I beta, so we should find the number of P intersection Q. This is a very simple question. It's most of the times confuse students. So the number of P intersection Q simply means we should count the number of intersection we got in alpha. So we have 1, 2, 3, 4, 5, 6. So our answer for beta should be 6. Very simple answer over there. And we have gamma. So gamma is saying that we should find the HCF, that's the highest common factor of 36 and 54. So what should be our answer? Highest common factor of 36 and 54. So in this case, for us to know the highest common factor of 36 and 54, we should use the P intersection Q, because if we use the individual sets, we can have 36 here, 54 here, but they can't be the HCF because they are different. Okay, so now let's use the P intersection Q. When we use the P intersection Q, the HCF here should be 18 because it's the highest factor over here, or the highest member over here. So our answer to gamma should be 18. Yeah, our answer to gamma should be 18. So, and B, question B says we should write down the next two terms of sequence of 1, 4, 9, and we continue in that order. So how do we know the next two terms? We can factor out the next two terms using two different methods. And the first method I'm going to show you is using the method of odd numbers, okay, in this case. So when we take 1 and 4, we should find the difference between each member. So the difference between these two members is 3, and the difference between these two members is 5. Now we can see that we are creating a pattern. So now let's follow the pattern. So if we are creating a pattern to follow up with the pattern, we have 3, 5, the next should give us 7, right? Now, what number do we put here to get a difference of 7? It should be the number 16, right? So our next number should be 16. So when we give a difference, we get 7. Now, what is the next sequence? Is 9, right? Now, what number do we make a difference with 16 to get 9? Is 25, okay? So 25 gives a difference with 16 to be 9, okay? So now we can have our next two numbers to be 16 and 25. The same way, let's use another method, and this method is squaring method. I'm going to use another method which is called the squaring method. Okay, so if we are having 1, 4 in the question, it gives us 1, 4, and 9. Okay, so now how do we get the next two terms? To get the next two terms, we are going to square the numbers which follows each term. Okay, the numbers which comes after each term. So let's square 1. When we square 1, we get 1. So let's leave it like that. Let's square 2. So 2 squared should give us 4. You can see that we have 4 there. Now let's square 3. 3 squared should give us 9. We have 9 here. Let's square 4. 4 squared should give us what? 16. So our next term is 16. Let's take 5. Let's square 5. 5 squared should give us what? 25. So our next term is 25. Okay, so our next two terms should be 16 and 25, either using the odd numbers method or the squared method. So if we are to continue to get the next 3 terms, we use 6. So 6 squared should give us what? 36. That will be the next term. Okay, very simple.